we're starting to. Certainly, if anybody happens to know any millionaires or billionaires who love radio astronomy, please have them contact us too. More than one would be nice. But we're beginning to reach out, but that's a difficult and typically a fairly slow process as well to get people involved and to have them step up. We need sustaining funds, not one-time funds, which is a very different ballgame. It's more straightforward to get somebody to donate to a single facility than it is to say we need funds to continue for us for many, many years to come. So that's where it's a slower process. But we do have the ability for donations and things like that. All of that's already set up, so we can do that.
What's the opinion of your fellow astronomers throughout the world? Are they willing to give up green bag in order to get the new ones? Would they want to hold on to green bag and give up, you know, something new and fancy?
So let me take a few communities, and that might be an easier way to answer it. Looking internationally, the GVT, although the majority of our projects here on the telescope have U.S. observers on them, astronomy is an international game. So there's a huge number of international astronomers that also use the telescope, usually hand in hand with the U.S. astronomers, which personally I think is fantastic. It allows the people in the U.S. to be working with the best in the world. So we have a telescope. There's a telescope that is technically very similar to the GVT called Effelsberg. It's in Germany. It's another 100-meter telescope that's fully steerable. Not quite as big as the GVT, a lot of details in there. It's a much older telescope too. One of the recommendations within the report when they said, well, if they recommended divesting the GVT from the NSF astronomy portfolio, they said, well, U.S. astronomers can apply for time on Effelsberg, this other telescope in Germany, to do their science at the higher frequencies. For many technical reasons I won't go into, that's simply not true. And in fact, the directors of Effelsberg have agreed with that fact. And they are helping us to try to make sure that the astronomy community and the National Science Foundation understand why it is that the statement that Effelsberg can be used for many of these science just isn't the case. You would have to spend more money than it would take to rebuild the GVT to fix a lot of the issues with Effelsberg because it's an older telescope. So there's one type of community. Certainly the astronomy community, the user community of the GVT, the user community of radio astronomy data in the United States and around the world are very upset about this. And they are not happy about the closure of the GVT or the VOBA. The astronomy community as a whole, in some cases, people can become fairly isolated in terms of learning to become an astronomer to work in a very specific wavelength regime. And when you do that, sometimes you don't realize that the information that you're using came from a radio telescope. And that's part of the education process that has to happen. It sounds confusing, but if you think about any specialty field, if you work on a certain type of thing, you might not understand where the widget that you're using to fix that item came from. And that's how astronomers can think sometimes. If you're studying stars and you tend to use the Hubble telescope, when you only exclusively use the Hubble telescope, to take an extreme case, if that were the case, when you write your data, you might talk about, oh, okay, well, I already knew this fact and that fact and that fact about the star, so here's how my information feeds into it. And what you might not realize is these 4 facts came from the GVT, or came from the VOBA. And so that's part of the education process. It's not a surprise, again, to use the analogy, when I fix my car, I don't know exactly who built the socket and how they built the socket that I'm using to get on it. And it's a very similar thing. Astronomy is a very wide field. And so part of what we're doing in our response is to just make sure that the astronomy community has a very clear picture of what would be lost if the use of the GVT was lost to them. And that's what we're trying to do, and try to make a very, very clear picture for them of that. Yeah.
You had, Don Jennings, my name. You had mentioned earlier about working with different, like WVU, would it be advantageous to somebody to work directly with them so they can bring their students down here instead of shipping them off somewhere?
WVU students come here now. I'm incredibly pleased to say that in the last 10 years, so about the last 8 years now, ever since WVU started to expand their astronomy program, our connections to WVU have started to increase, not just in astronomy, but we're also seeing an increase in connections with the engineering program there. The astronomy program is fantastic in the sense that we actually see WVU students here almost to the point of distraction. They're down here all the time. It's wonderful. In the summertime, we'll have 10, 15 WVU students here. All of the astronomy professors are here frequently. I'm actually an adjunct at WVU. They're adjuncts here, which means that we pass back and forth, we pass information back and forth. The state of West Virginia has seen fit through the stimulus funds to make to broaden the network connection from our site up to WVU, to increase those connections. So we're actually talking about things like in the new astronomy building, they have a lab set up specifically, kind of terrifying to me, but specifically so that they can have me call into my office and help teach classes and help students there, and vice versa. So that connection is tightening. The engineering connection, we always have a few WVU students working with us, and we're hoping to increase that. So an increased connection with WVU is important. The flip side is, because we've been increasing those connections steadily, the loss of the GBT to WVU would also be very significant. And so we have been talking with them some about that, but the conversations so far have been waiting a little bit more to wait and see how the conversations between the senators and the NSF go.
Well, once they win 12 football games, they ought to have plenty of money.
I refuse to comment on that, but you're probably right. Just put a little box right next to the, the $2 fee on all the football games. But that is certainly one option, and I think, to be fair, West Virginia isn't the wealthiest state out there. But WVU is an important facility for us. I don't know, I'm not privy at all to WVU's finances, and I don't know whether they can afford to help pay for the site, the whole site, I doubt it, but the possibilities of some collaboration with them is certainly out there, and something that we're pursuing to see if they can help out. I think we're important to them, and they're also very important to us. So that connection.
I was just sitting here thinking, when the VLA moved their main site from out where the VLA array is into Socorro, New Mexico, and the New Mexico Tech campus, the state of New Mexico paid for that building. Is that not correct?
There's a one-time deal, though. Again, that's the problem. It's much easier to get those one-time fundings than to get the...
Didn't they build it about 3 times bigger than the number of employees at that time, which they knew would eventually fill that building?
But we pay rent on that building.
Oh, do we pay rent?
Yes.
Yes.
So they built it, but we lease it. So there's a significant cost, annual cost to it.
Okay. So with the initial building.
I mean, the state of New Mexico has certainly helped out in many ways with the site out in New Mexico. So the facility in New Mexico runs a very large array and a very long baseline array. They've helped out, but again, those tend to be the one-time donations and not the sustaining funds that we need to keep this site going.
Yes, Jerry.
Dr. O'Neill, maybe it would help for people to understand why the NRAO and the NOAO were originally created, to kind of explain that, it was trying to get rid of the exclusiveness of the best instruments.
Yeah, so the U.S. National Astronomy Facilities were conceived back in the 1950s at a time when science was big and astronomy was an ever-growing field. And the realization had come to the U.S. community that if they really wanted to be a player in astronomy as a science around the world, then we needed these national facilities. And the reason was other countries were starting to build national facilities. And, well, it's maybe not straightforward for all of us, but straightforward for somebody to try to build something like the Jansky antenna that you see outside. You see the replica outside. It's something that can be built at home. You have to know a lot, but you can do it. The cost itself of building the antenna isn't that high. But as you kind of hit that more straightforward to hit type of structure, you start to hit deeper skies, you need more precise instruments, you need more sensitive instruments, it becomes more and more expensive. And so the result of that was in the 1950s, the National Science Foundation, working hand in hand with a lot of universities around the country, decided that we need these concepts called national astronomy facilities. The idea behind a national astronomy facility is that these facilities would be open to anybody. Didn't matter where you were or where you came from. Anybody could come and use these facilities for free. All that it took was that you had the best science proposal to use it. That idea, called the Open Skies Policy, has been the basis for the National Radio Astronomy Observatory and the National Optical Astronomy Observatory for our entire existence. And it's, personally, I think it's why the telescope put out such great science, because it means the best scientists in the world are using our facilities, and they get the best possible data as a result. It also means that U.S. astronomers get the opportunity to work with the best in the world. Whoever they are, wherever they're from, U.S. astronomers can work with them and then also become the best in the world. So it's a fantastic idea. Within the radio and optical community, there are other telescopes out there that don't work underneath this open skies policy, far more so in the optical than the radio. But the radio, they tend to be fairly small too, I should add. And in those cases, you have facilities which are typically owned by one or a small group of universities. And in most cases, only students from those universities and faculty of those universities are allowed to use the telescopes. So one of the losses, then, to go back what I talked to a bit about earlier, is if the NSF divested the GBT, and let's imagine, let's take an extreme case, imagine WU, some football donor decided they really liked astronomy better, so they poured all their money into the astronomy facilities here. That would be fantastic for WU, but WU would have the option then of saying, well, this is a facility for our students and for our faculty. That would be great for the state of West Virginia, not so great for the rest of the country, because other astronomers wouldn't be able to use it. And if it was just WU, then even the small colleges within the state would have the potential of being turned down for it. So that's a concern for us, is the loss of this open skies policy as we start to look at other funding opportunities.
Well, that's, oh, I'm sorry. Karen can hit me later. I'm going to be a little more pointed to your question.
No,
The national facilities were created, and I quote, to keep the United States scientific community at the forefront of science. What concerns me is that they're closing the national facilities and putting the money in other parts of the globe.
Right.
And that was my question, actually. Did the NSF give any reason as to why they're taking federal money from this country and putting it into new facilities in another country?
An astronomer will answer you. Astronomers are global.
And let's be careful. So it is, the facilities are being built down in Chile, it's true. But for all three of the facilities on the list, there will be some level of access to U.S. astronomers. And I'm saying some level because the U.S. is not necessarily funding for the complete build of them. If you're not going to pay to build the whole thing, you don't get full access to the whole thing. The reason astronomers are global is because we have to keep moving away from all these other people all the time. And so we're trying to go to areas where you have a very dry environment, and you try to go to an area that's very underpopulated, even for optical astronomy. You don't want light, the same way we complain about radio noise, you get the same thing with light pollution around you. So you want to go to a place that doesn't have any light pollution, or doesn't have any radio pollution, and that is very dry. And to get a very dry atmosphere, you get two things. First, you go to a desert, but that's not good enough. You want to go to a high desert, so you're actually moving up in the atmosphere, and you're reducing the amount of stuff you have to look through to get to see the astronomical objects you want to see. That's why Chile currently is very popular. Chile is very popular. It's a stable economy with a stable government that has a fantastic eyesight. It's very, very high. And so the result of that is Chile's always been popular for astronomy. There have been for a very long time optical telescopes and radio telescopes down in Chile. The National Radio Astronomy Observatory is a partner in a major telescope that's being built down there called ALMA. It's one of the biggest, well, it's the biggest project that the National Radio Astronomy Observatory is taking part in. So all of that is very real, and for astronomers it's very important. However, I can say that it is very difficult for students to get to Chile. It's very difficult to get to the high sites. And because of that, if all that existed were telescopes down in Chile, then the astronomers like me who already knew what we were doing, we'd be in pretty good shape. We could use them remotely, we get it. It's the students that I worry a lot about, and the student access to the facilities. It also worries me because when you have a telescope that's not, I mean, part of the reason people like to come to the GBT, I mean, we have a fantastic tour center, yes. But if you got rid of the big telescope out there, I don't think we'd see 50,000 visitors. It's cool, it's fun, and it's neat to see it, and it's neat to see it working. And so that public outreach component also has the potential for being strongly effective.
You answered my question. I think nobody really ever understands that it's difficult to convey the concept that, for example, if Sheriff Janice tonight went home and had a brainstorm, and he wrote down his proposal and he submitted it, he could get time on the telescope at no charge. You know, if I went home and I suddenly said, gosh, this is a great way to figure out dark matter, I could write a proposal, send it in, it'd be peer reviewed, and if it was approved, I could get time on telescope for free. And then that's the magic of this National Science Foundation funded environment is, I don't have to go to school at WVU or the Ohio State University or anywhere else. You know, if I'm clever enough, I can write a proposal and I can get that data and try and figure something out about the universe.
I have a quick question, Karen. Can you give us an idea of what kind of time frame all of this is going to transpire?
So,
Less than a luster.
when the report was released, the National Science Foundation stated on their webpage that they would have divestiture plans in place by December of this year. So that is their current plan. I am suspicious that that might be an optimistic plan on their part, but that is the current official word on this. What that does mean is that if we're going to change the divestiture plans, if we want to have an impact on them, it's now. We have to do things now.